Library functions. We've used a lot of functions so far. The very first two that we learned were CLC and clear. After that, we moved immediately to trigonometric functions or basic math elementary functions. And then further on, we moved to input and output functions, input and fprintf. But what's really behind a function? Generally, a function is a set of commands which are grouped to perform in sequence. For example, the cosine is nothing but an addition, repeated addition. So MATLAB combined all these additions together and grouped it under the keyword COSD. The function is provided a name so it can be reused as many times as we want. There are a foundation of modularity, which means they can be reused. That sequence of command is written by someone, and then we just reuse it by reusing the keyword. We also know that if there's a problem with that function, we can easily go into the function itself without messing with the bigger picture. So far, we've only used built-in functions, meaning they came when you bought MATLAB. But this won't always be the case. In the future, we will create our own keywords. Now, the vocabulary is very important, not only because the entire documentation of MATLAB refers to those words, but also it's the same vocabulary across all programming languages. So that's one good thing. If you understand how to use a function in one language, you can usually read the documentation in any other language. Even better, it's also the same vocabulary in Excel. So Excel offers a lot of built-in functions that you can use as well. There's only 3 vocabulary words: the function call, the argument, and the return value. Let's see each one by one. The function call is actually the most important part. It's the actual line of code that calls upon the execution of the function. Remember that a function is nothing but a name to a sequence of commands. That sequence of commands is hidden behind the scenes, but it's a keyword that we're going to reuse over and over again. So we call upon the execution just by writing the keyword. For example, CLC is the function call to clean up the command window. Clear is the function call to clear the workspace. Input is the function call to ask the user for their age. I've grayed out the beginning part and the part in parentheses. That's not really the most important part of the function call. The call of the function is you actually writing that keyword so that MATLAB recognizes that you want to execute whatever is hidden behind that keyword. The other 2 parts are the other 2 vocabulary. But before we go on, test your understanding. Pause and count how many function calls there are right here. If you're having a little bit of issues, count the keywords that you are not responsible for. There's 9 function calls right here. CLC, clear, and format are the first 3. The length and the angles are variable names. Those are not keywords that MATLAB executes behind the scene. But however, on line 14 and 15, we call 4 times a trigonometric function. Cos D, sin D, sin D. On line 18, we call SQRT. And on line 19, we do fprintf. So there's 9 function calls right here. How about this one? There's only 3 function calls right here. CLC, clear, and at the very bottom, fprintf. Now, moving on to the second vocabulary. The arguments are the input needed for a function to process. If you would have written x equals square root open parentheses, MATLAB would crash. If you want to calculate the square root of a number, you need to provide that number. That's called the argument. For example here, this required 1 string argument. Strings usually are in quotes and show up in purple. But without that, MATLAB cannot process the input function. The sin D function requires a numerical argument. In this case, again, if we did not put anything inside the parentheses, MATLAB would crash. Some functions can accept 1, 2, or 3 or more arguments. For example, the input function can use 2 arguments, both strings. Now all these examples here show hard-coded arguments, meaning that when you run the code, this is always the values that are going to be sent to the function. But that's not always the case. In most cases that we've done so far, we've used variables to calculate sine d of an angle. The order of the argument is absolutely crucial. For example, which call down here is correct? It's either B or C, because the first argument of the fprintf function is the format string, and strings are usually in purple. But between the two, we know that the orbit number needs to display first, so C is actually correct. The other options are not valid at all. The first argument is orbit number, and that is not a string, so in this case, MATLAB would crash. Last but not least, the return values. Some functions do not calculate anything and therefore they do not return values. CLC and clear do their job but do not give you back a result. Now, most functions that we use, especially as engineers, we calculate something and therefore return the value. They can either be numerical values or even string values. Sine d of an angle in degree calculates the sine of an angle, so we get back a numerical value. Square root calculates a distance, for example. Even input returns a value. It is a string, but it returns data to you. In all these cases above, the program should collect the return values in order to use it. Let's go see. This code calls the function CLC, calls the function clear, calls the function input, and passes the argument here, the string, enter x coordinate. The other one calls the function input, passes another argument, enter y coordinate, and then we use the actual square root to calculate the distance. But when I run this code and I enter the values, something strange happens, and even an error message on line 11. So line 11 calculates the square root of x squared plus y squared, but x is not defined. While these functions got executed, it did work. MATLAB did ask me for a value, I did enter a value, MATLAB collected it and put it in answer. As a programmer, I did not collect the return value. So there's no way for me to actually use that value later. So collecting the return value simply means bring the actual value back into a variable. So here's x, and here is y. In this case, when I enter 2, MATLAB collects the value and puts it in the variable x. So now I can put a semicolon here. When I do the same with y, MATLAB collects the value into the variable y. So again, I can do the semicolon. So, line 11 no longer crashed. X is known, y is known, MATLAB collected the value, but since I did not specifically indicate a variable, MATLAB used ANS again. So if I code more below, I won't be able to go far. If I run this, 2, 3, MATLAB crashes, because on line 12 I am referring to distance, but distance was never actually given a value. So again, this function returns a value. I, as a programmer, need to collect it into a variable name. And that concludes that program. So I have 1, 2, 3, 4, 5, 6 function calls. I am passing one argument here, another argument here, one argument here, although it is the result of an equation, and then another argument here. The first one is the string, the second one is the variable x, the third one is y, and the fourth one is dist. But I am doing a function call for fprintf. and I am collecting 3 return values, all in separate variable names. So always remember that if you write a function call and it returns a value, collect it in your own variables. The key points here are to learn the vocabulary. While there's only 3 vocabulary, it's actually the same one for all programming languages. So that gives you a tremendous insight in all the other languages out there. The function call is what makes the actual keyword execute. So we call upon the execution of whatever is hidden behind that keyword. The arguments are the inputs to a function. There can be 0, CLC and clear have absolutely no arguments, or they can be infinite. fprintf has no limit to how many variables you can put. The programmer, however, must provide all the arguments when calling a function. Just missing one makes the function crash. The return values are the output of a function. The programmer chooses whether or not to collect them by storing in a variable. There can be 0 return values again. CLC and clear do not return a value. But they could be infinite. So far we've only collected 1 return value. In the future we'll learn how to collect multiple return values. The programmer chooses whether or not to collect them. That's a choice that you make. But that concludes the introduction of the 3 vocabulary words for functions.